Okay, this is video A, which is the mean calculations, and oops, what you can see on the screen here is a large-scale copy of the table that you'll see in the slide set. Now, this part here is what we've already seen, because this is the group frequency distribution, which is the summary output of the kind of summation and organisation of the raw data. And if you remember, we talked about the classes and the idea that this means there are 12 values or 12 items that are within that class. Okay, and again, we total these up and we see that we've got 120. This actually confirms that we've done it right, and it's a useful check to make sure that you've got all the data right. Now, what we are going to do with the data in this form is that we're going to find the mean, which means we are going to take representative values for all 120 items and effectively provide them with the total. But I'm just going to lead you through the steps that we do this from. This process is exactly the same for all the other exercises that you will see, and the tables are drawn up in the same way. You won't actually get the table completed for you in the exam. You'll have to do it. But remember, you're going to get the data represented in this form. So what you need to do in the exam is then to put these extra columns in and then do the calculations. Just a key word on these classes. Now, we said that it might seem a little bit strange that we've got this 400 to under 420 and then the next one at 420 to under 440. Now, if in each of the classes we put 400 to 420 and 420 to 440, it's possible if we had a single value of 420 that you could put it in either class or you could put it in both classes. Now, this means that there will be a lack of accuracy in the data, and there is a technical reason why it's under 420, but we don't need to worry ourselves about it now. Okay. Now, what we need to do is to try and find a way to represent these 12 values as being a single value for each one. And you'll see here, we've got this thing called a class midpoint, which we abbreviate as MP. And so what we're doing in this table is all these 12 values that are in there, in the data in this form, we don't actually know, unless we go back to the original data, exactly where all those 12 items lie. And so you might assume that by assuming that each of those 12 values is at 410, actually represents some kind of lost detail, and in a way it does, but we needn't worry ourselves with the technicalities of that. Just to try and explain this on a drawn diagram. Now, this may or may not work very well. So we've got 400, okay, and this class stretches all the way almost to 420, but not exactly. And so you can imagine that there's a very, very small gap between the value that will be included in that class and one that will be in 420. But if we ignore this small value, because it's infinitesimally small, what it means is the width of this class is 20. So if we're looking for the midpoint, it seems fairly clear that it will be here at 410. If we add some different data, for example, we might see one of the other exercises where we might have a class that goes from 50 to under 60, then even though it doesn't quite reach 60, there's this very small gap, but the class width there would be 10, and the midpoint in a class like that would be 55. So even though it doesn't describe it exactly there, these are the calculations that you do that would establish that midpoint. Now, if we see the next class, we see that effectively we repeat these same sort of kind of calculations here, and we end up with 430. If the class interval of 20 is the same in all classes, which it is, then what it suggests is that the midpoint itself increases by 20 every time. And in this case, for these calculations, once you've established what the midpoint is and you're happy that you've got it right, you don't have to repeat this every single time. You know that you can advance this midpoint by the width of the class. And if you look at these, you can see that does make a certain amount of sense. So we have this class midpoint. What we're then going to do is we are going to take these 12 items here and we're going to multiply it by this midpoint, which represents all the 12 values in there, and that therefore equals 4,920. You can take it from me that that calculation is correct. And then what we do in each of these classes is we then take the 27, multiply that by the 430, which gives us that amount. We must multiply the 34 by the 450 that way, and so on and so forth. The advantage of this is we do the same thing every time. So once we know how to do it, we just repeat it. And you'll find, if you can be bothered to do the calculations, that these calculations are all correct. And so what we've actually got for the 120 values is in each class, we've given them an average value, if you will, and multiplied it through. So this here represents the totals of all 120 items that we have, each multiplied by our respective midpoint. And we therefore get this total of 54,540. And this is what we then designate as sigma n, the total of all individual items. You can then see that down here, we have this calculation where we take that total, 54,540, divide it by the number of items that we've got, and therefore we have the mean of 454.5 kilometres.